Okay, so for the first one, do we use the rule that's like sine then brackets a plus b?
Mm-hmm. And it's given to you. Yes.
So then we write sine theta cos pi over 4 plus cos theta sine pi over 4.
Mm-hmm.
We want it to factorize, I think, to the top bit, but I'm not sure.
What is cos pi over 4?
Root 2 over 2.
Okay. What's next?
Sine theta
Yep.
plus sine pi over 4 is also root 2 over 2, so plus root 2 over 2 cos theta.
Mm-hmm.
And then that we can factorize to 1 over root 2 brackets sine theta plus cos theta.
True. Because 1 over root 2 is the same as root 2 over 2. Just rationalized. B.
So it's equal to 1 over root 2. So it's not like a quadratic, so we can't do it like that.
What is 1 over root 2 sine theta plus cos theta the same as?
One over root 2.
Anything else? Given that they said
Theta plus pi over 4.
yes, and so instead of writing this, you could say sine theta plus pi over 4 is equal to
1 over root 2.
boom. And so you could solve that.
Okay, so first would we do like let a equals theta plus pi over 4, and then we will have sine a equals 1 over root 2.
Well done.
So now with that, then a equals sine to the minus 1 of 1 over root 2. Which gives us 1 over 4 pi.
Okay.
So, and then do we have to work out the values of a? between that range. So if it's sine, how often does sine repeat? 360.
True. That's how you get your third answer. How do we get our second?
Plus 180.
You're
Or
thinking.
180 minus
Yes.
1 over 4 pi. So.
And what is 180 in terms of in radians?
Pi.
Yep.
Okay, so 3/4 pi.
Is it?
And then also, is there going to be 2 more answers?
No, that's it.
Ah, okay, so now we need to get it out of A and back into the other one. So those answers are the same as theta plus pi over 4.
So theta plus pi over 4 is equal to 1/4 pi and 3/4 pi. And so theta
minus pi over 4 from those answers.
Yep.
So 1 over 4 pi minus 1 over 4 pi. So 0. 3 over 4 pi minus 1 over 4 pi. 1 over 2 pi and 0.
And because it's a very special case, I may have skipped over something. So we were doing theta plus pi over 4. So what is the range for theta plus pi over 4?
Oh, is it 0 plus pi over 4 and then 2 pi plus pi over 4?
Yep.
So the lower one will be pi over 4 and then the upper one 2 pi plus 1 over 4 pi is 9 over 4 pi.
And so you said sine repeats every 360. So add 2 pi to our first answer.
So what was it? 1 over 4 pi plus 2 pi equals 9 over 4 pi.
So it's just in the range. So that's a third answer.
Wait, but can we not say 0?
We can't. So our...
Oh, because that's when we change it back. So it works.
Yeah.
Okay, so for 9 over 4 pi, then do you do minus 1 over 4 pi?
Yeah.
Okay, 2 pi.
Yeah, and so this is the special case where it intersects it 3 times because it's going through 0. 0, a half pi, and 2 pi. And any idea about 3? You know this equation they gave us 1 over root 2 sine theta plus cos theta equals 1 over root 2.
Yes.
Divide both sides by 1 over root 2. What do you get?
Sine theta plus cos theta equals 1.
Yep. And so they're the same.
Oh.
And therefore...
Do they have the same answers?
Yep.
Oh, damn.
So theta equals 0, half pi, 2 pi. I hope so anyway. Let's take a lookie. 0, half pi, 2 pi. Yep. Yes, those are the answers. And A was, yeah, just show that. Okay, let's see. Big picture, just put it in our formula. And you simplify this bit. Cos pi over 4, sine pi over 4, just put that in the calculator. B, hence, so you take a very difficult equation like this one and you solve it using what you did in part A. And then C is just the same thing. Any questions?
No.
Let's see. How would you do part B if you weren't able to do part A? No. Hang on. Nope-de-dope. Okay, we'll do it. Alright, what is part A?
So do we have to use that rule again with the sine A plus B?
Yep. In this case, it'll be sine A minus B.
Oh, yeah.
Which is given to you just with a minus in between. What would you do with that?
So you would do sine x cos 45 minus cos x sine 45 is equal to cos x.
So it's not equal to cos x just... Oh no, you're right, yeah. Okay, go on. There shouldn't be a
But
How did you do part A in this one?
subbed into the equation. Oh, then we worked out pi over 4 in the calculator. So now we work out cos 45, which is, we need to be in degrees. Okay, is root 2 over 2, and then sine 45 is also root 2 over 2.
Okay. And so?
And then just add in the sine x minus cos x after the, yeah. Now can you plus the root 2 over 2 cos x to the right hand side?
Yep.
Okay, so that's like 1 plus root 2 over 2. So that gives us 2 plus root 2 over 2.
Okay. What's next?
Now, will we divide both sides by root 2 over 2?
No. You have a mixture of sinx and cosx. You're trying to get tan x.
Divide both sides by cos.
Yes. You could have done that a while ago. But okay.
Oh. Oops. So now we have root 2 over 2 tan x is equal to 2 plus root 2 over 2.
Yep.
And then would you divide both sides by root 2 over 2?
Yep.
Okay. Gives us 1 plus root 2. So tan x equals 1 plus root 2. So a equals 1 and b equals 2.
Well done. A equals 1. B equals 2. So tan x equals 1 plus root 2. Part B.
So x equals tan to the minus 1 of 1 plus root 2.
Yep.
Which gives us 67.5. And then tan, do we add 180 to that?
Yep.
So now we have 247.5.
5. Any more solutions?
I don't think so.
Me neither. 67.5, 247.5. Well done. Any questions there?
No.
Destroyed it. Let's see. So, a bit more complicated, but it's the same idea. Just sub it into your formula. Then, hence, change solve. Find the value of theta. Now, give me a diagram or I'm not doing it. Show the tan. I think it's just going to be the same idea, really. Just sub it into your formula. Monkey around with it. Yeah, sub into formula, hence solve, sub into formula. Yep. I think there's nothing more to it. So, yep. It's all about whenever you, it's same. You just put it into your double angle formula. This one is a bit weird. Do we do this in the next thing? Do it in the next thing. Any idea how to do this one?
So we write cos brackets 2 theta plus theta.
Mm-hmm.
And then can we use the formula that's 4 cos A plus B?
Yep. And I think you'd be fine for the rest, to be honest. I think you have the idea. Okay, those stuff.
Half.
Half. I'll give you a half. Okay, this stuff. Okay. I have an old lesson for it. Might be more confusing than not, but you might have no idea whatsoever. What would be steps 1 and 2 of solving the first one? Nah, part C. What would be step 1 of solving it?
Get divide by cos.
What would you get?
3 plus 4 tan x equals 0.
Yep, tan x equals 0. 4 tan x equals -3. Tan x equals -3/4, and so x would be whatever arctan of -3/4 is, and then you would just keep adding 180 until it's within your range. Okay. How would you solve this one?
So divide everything by cos x.
What would you get?
We'd get 3 tan x plus 4 equals 1 divided by cos x, 1 over cos x.
Yeah, which is like sec x or something. But the thing is, you had a mixture of sine and cos. So you divided by cos, but you still have a mixture. And so how do we deal with this? This is how. 3 sine x plus 4 cos x equals 1. We put it into our graphical calculator. What is the period of y equals 3 sine x plus 4 cos x? So basically, how often does it repeat? And this is my thing here. It's in radians. Any idea how often it repeats?
$360.
Yep. 360 degrees or 2 pi. What is the amplitude, the height of that blue line?
5.
Yep. Let us see. 5 sine x plus 12 cos x, 7 sine x plus 24 cos x, 1 sine x plus 1 cos x. All three have period of 360 degrees, just like this one. For our one up here, 3 and 4 gave us amplitude 5. 5 and 12, amplitude 13. 7 and 24, amplitude 25. 1 and 1, amplitude root 2. Can you find some connection? Is there any connection between those first two numbers in the question and the third number in the answer?
It's like it's one higher than the number before cos.
Pythagoras. 3 squared plus 4 squared, square root it, you get 5, and so on for all of them. Let us see. So what do you think would be, so what is B5 down the bottom?
So the period is how often that the graph repeats.
Mm-hmm.
4. Oh wait, no. 360.
Okay.
But the amplitude would be 4.
How'd you get 4?
I don't know. It's one bigger than the cos.
Root 2 isn't one bigger than the cos.
Wait, so do we do 2 squared plus 3 squared?
Sure do.
So we get 13 and then root 13.
Root 13 is fine.
Yeah.
Root 13. And then you could check the graph. Okay. So that is, there we go, root 13 and 360. If you were to actually plot it, root 13 is approximately 3.6. Let us see. Draw again the graph of y equals sine x plus cos x. This is what it looks like. It looks as though you can transform the graph onto y equals sine x. An enlargement of y direction scale factor root 2. So if the amplitude is root 2, then it would be like y equals root 2 sine of something. It looks like it's the sine graph but moved 45 degrees to the left. And so what would that be? How would you write that, the equation for that transformation?
Yeah. I think it might be plus 45 for that bit.
Yep, x
like
plus...
Yep,
x plus 45. And so, let us see. Yep, that's it. So that's the equation. The Pythagoras bit, the amplitude bit goes there, and then the transformation goes in there. So using our formula, we'll try to expand this. So A is x, B is 45. And we'll times the whole thing by root 2 at the end. We would get sine x cos 45 plus cos x sine 45. And actually we did this a minute ago. We got root 2 over 2 sine x plus cos x. What is root 2 times root 2 over 2?
One.
And so we get 1 sine x plus 1 cos x, which verifies that we did it correctly. You can do this forwards. You can also do it in reverse. So they can give us y equals sine x plus cos x. And we can say this number is 1, this number is 1. So the Pythagoras of it will be root 2. And we can compare the coefficients. So we can say, we can compare this and this, like, because these sine x are the same. And this, because the cos x is the same. So we'll come to that in a second. Okay, so this one. We could write this as something sine x plus something else. The r, the coefficient, is the Pythagoras for these two. So what is that? I think it was root 13. I think it's the same.
Wait, I'm confused what that R means.
It is just like the coefficient. So instead of it being sine x and cos x, we're just going to write it as something sine x plus something.
Okay.
Instead of having sine x and cos x, we'll just have sine in terms of a double angle. So we're going to go from a double angle answer back into the original double angle thing. Okay, so double angle formula, root 3. What would it be? Do you remember the formula for sine double angle? And what would it be for these two values?
I think, is it sine x cos, what's that called?
Alpha.
Alpha plus cos x sine alpha.
Sine alpha, yes. And then, so we know that it has to give us 2 sine x and 3 cos x. This sine x matches up with this sine x. So what does the 2 match up with? So my page might not be very big. No, that didn't work. Let me go in here. Yeah, this is better. So I know, working in reverse, I know that root 13 sine x plus something, calling it alpha, has to give us 2 sine x plus 3 cos x. We expanded this thing over here. We got root 13. We got sine x cos alpha plus cos x sine alpha. Let me make this even simpler. There's no root 13. Okay, match up UPUP. We have a sine x cos alpha, cos x sine alpha. What matches from the top?
Sine x cos x.
So these two sine x's. So this is 2 times sine x. This is sine x times cos alpha. What do you know about 2 and cos alpha?
They're equal.
So 2 equals cos alpha. What else do you know with the second half?
3 is equal to sine alpha.
Yeah. And so what you have there, how can you solve for alpha with these two?
Simultaneous equations.
Yes, and the way you do that with trig is you divide them. What is sine alpha over cos alpha?
Tan alpha.
Yes, and so 3 over 2 equals tan alpha. And so what is alpha equal to?
And to the minus 1 of 3 over 2.
Do it.
Wait, does this have to be in degrees or radians?
I think it's degrees. It might not be exact.
Okay, I got 56.3.
So 56.3 degrees. And so we would just put it in here. So it was r sine x plus alpha. We said r is root 13. We said alpha is 56.3. And so what is another way to write 2 sine x plus 3 cos x? Just sub in our r and alpha. What was r?
Root 13 sine x plus 56.3.
That's it, 56.3 roughly. If you were to use the double angle formula and you were to do sine x cos 56.3 plus cos x sine 56.3, simplify it out and then multiply it by, like, expand the brackets by root 13, you should get very close to 2 sine x plus 3 cos x. We rounded it to one decimal place. And so this is essentially double angle formulae in reverse. Let's make it simple. This is like the solution for double angle formulae, or like addition angle formulae. The r, the coefficient, if we were to write this like working back into the addition angle, the r, the coefficient, is the Pythagoras of a and b, these two. The alpha is the arctan of these two, b over a. But we can do it as by inspection. Any questions so far?
No.
We'll practice. Let me go back to here. Good, got it. Sure. So this is our cheat sheet, this thing here. I think we've done enough. So now I'll just copy this. So now let us try this one. And our little cheat sheet is down there. So r sine x plus alpha.
Wait, so how do we start?
Pythagoras of 304.
So 25, so it'll be 5. And then, so if we did like sine b, a plus b, then we would get sine x cos alpha plus cos x sine alpha. So then we know that so 3 is equal to cos alpha, and 4 is equal to sine alpha. So if we divide that, then we get 4 over 3 is equal to tan alpha. So alpha is equal to tan to the minus 1 of 4 over 3, which is 53.13.
I'd say 53.1.
Okay.
And so 3 sine x plus 4 cos x in the form r sine x plus alpha.
5 sine x plus 53.1.
Well done. Same idea for b, except this time it's r cos x minus alpha. And you can use this stuff if that's helpful.
Okay, so what's the rule for cos A minus B?
It's similar. You always want to do cos A minus B. That is cos A cos B plus sine A sine B.
So we write cos x cos alpha plus sine x sine alpha, was it?
Yeah. So sine alpha
So does that mean that cos alpha is equal to 4 and sine alpha is equal to 3? Okay, so tan alpha is equal to 3/4. So add to minus 1 of 3 over 4 gives us 36.9 to 1k. Then what are we missing?
R.
Okay, so we work out R with Pythagoras.
Yep. So it'll be the same.
5.
Yep.
Okay, so then it would be 5 cos x minus 36.9.
Yes. And so you could write it as, so you have 3 sine x plus 4 cos x. You can write that as 5 sine x plus 53.1 or 5 cos x minus 36.9. Any questions there?
No.
Okay, so instead, so just working in reverse to put it back into the way you found it. That's going to be fine. It's going to be fine. Tell you why. Yeah, this is what we need to do. Okay, how do we do this?
So we use the rule for cos A minus B. So I think we'd have cos theta cos alpha plus sine theta sine alpha. And then so we see, okay, what matches up. So 2 cos theta, so the cos alpha will be equal to 2, and then sine alpha will be equal to 5. So if we do, so tan alpha equals 5 over 2, so tan to the minus 1 of 5 over 2 gives us 68.2 for alpha, and then 2 squared plus 5 squared equals 29, so root 29 will be the R. And then do we just write that as
Mm-hmm.
root 29 cos theta minus 68.2?
Yeah. Root 29 cos theta minus 68.2. B.
So it equals 3. So we can use the root 29 cos. So root 29 cos theta minus 68.2 is equal to 3. So if we did cos, okay, if we let a equal theta minus 68.2, then we're going to have root 29 cos a is equal to 3. So then if we divide the 3 by 29, both sides by 20, root 29, that's complicated.
I'm happy to leave it as 3 over root 29.
Okay. And then now a equals cos to the minus 1 of 3 over root 29. Which gives us 56.1. And then we have to look at all the values as a first. So up until 360, and it's, what is it, cos. So I think, do we add 360?
So our range, theta is between 360 and 0. What is theta minus 68.2 between?
Minus 68.2. And 291.8.
So it might not change anything, but just in case. Because A is theta minus 68.2, so A is between those two. Okay, so our first answer is valid. Okay, second answer.
Okay, to get the second answer, I think, so cos, do we add 180 or 180 minus that?
First one was tan, second one was sine. This is cos.
Plus 360?
Yeah, 360 plus.
But it doesn't make sense.
No, you're correct. 360 minus.
360 minus 56.1.
Yeah.
Is 303.9.
303.9, so that's outside the range.
But that's for A, and then if we, A is equal to theta minus 68.2, so...
Hold on. It's outside the range. So how can we use it to get an answer that is in the range?
Do 360 minus that.
Other way around. So 303.9, go left 360. So 303.9.
Minus 360. Minus 56.1.
Yes, and that's because it's symmetrical about the y-axis. So A is plus or minus 56.1. What is next?
To change it into back out of A, back to like theta and that.
Yeah.
So
Go on, tell me for me.
So A is equal to theta minus 60 something.
Oh, sorry. 68.2.
So A has to be equal. A is equal to that. So theta is equal to A plus 68.2. So we have to plus 68.2 to the answers.
Mm-hmm.
So minus 56.1 plus 68.2 gives us 12.1, and positive 56.1 gives us 124.3.
0.3. And when you were racing off with your 303, if you were to add 68 to 303, it'd be more than 360. And so that's why I had to stop you there. Yeah, see, if you change the range for A, because we have it slightly differently, then stick to that range. The answers will be valid, they'll just be outside the range we want. So that is theta. Let's check. 12.1, 124.3. Great. Big picture is this is given to us as single angles, but it's a mixture of sine and cos, and so we put it back into a addition or subtraction angle so that we can solve it more satisfyingly. Yes, remember this thing?
Yeah.
Okay, try it again.
Okay, so do we do 3 squared plus 4 squared to get the r?
Yep.
So r equals 5.
Yep.
And then, wait, is there an alpha? Or is... No.
Alpha. So which one will we use, sine or cos?
Sine?
Okay, so alpha, tan alpha is b over a.
So tan alpha.
Because we'll always do that simultaneous equations thing.
Wait, so are we just skipping steps now?
Yep.
But what's B and A?
That's a, that's b.
So tan alpha equals 4 over 3. Oh, okay, I see what you mean. That's the simultaneous equations bit.
Yeah.
Then alpha equals tan to the minus 1 of 4 over 3, which gives us 53.1.
Okay.
And then we can have 5 sine brackets x plus 53.1.
Mm-hmm.
Is that it or no?
Solve.
Solve.
We tried to solve this, we couldn't.
Yeah. But now there's only one thing.
Yep.
But what's it equal to? Oh, 1. Okay, so it's equal to 1. So let's let a equal x plus 53.1. Now we have 5 sine a equals 1. So sine a is equal to 1 divided by 5. So a equals sine to the minus 1 of 1 over 5, which is 11.5.
Okay. And we didn't get a range, so let's just get 2 answers.
Okay, so sine we have to do plus 360 to 11.5.
That's third answer.
Third.
All 3, sine, cos and tan, repeat every 360. So that will work for all three. Sine.
That's
Second, that's
180
180
plus, no,
that's,
minus.
yeah.
So 180 minus 1.5, 168.5.
Yep. So we have A, but we weren't asked for A. We were asked to solve for X.
X equals, so A equals X plus 53.1. So X equals A minus 53.1. So 11.5 minus 53.1 gives us minus 41.6, and 168.5 minus 53.1 gives us 115.4.
I don't know, but let's say this is between 0 and 360. So how could we get 1 instead of the minus 1?
Wait, what do you mean?
So I'm just guessing, but minus 46.1. How could we only get two positive answers? So let's say the minus 46.1. Sorry, 41.6. That's invalid because it's negative. Let's say that's outside the range. How could you get one that is in the range from, like, let's say X was between 0 and 360?
So you want a positive value?
Yep. Now you can do third answer.
So from 11.5 plus 360 is 371.5, and then minus 53.1 equals 318.4.
Okay. And minus 41.6 plus 360. Is that same as your one, 318.4? Yeah, so you could just add 360 to that, but all good, all good. The method that you're using is in general. It's for all multiplying, dividing, everything. I'm just kind of, I know it'll work out. I don't know if that is, if they gave us a range, but 3 sine x plus 4 cos x. They asked us to change that. I'm pretty sure it's correct. Do I have 3 sine x plus 4 cos x anywhere? Similar. 4 sine x minus 3 cos x. Okay. I just thought it'd be pretty satisfying if I 4 cos x, 3 sine x plus 4 cos x. Oh, they did it as cos. Okay. Yeah, but big picture is mixture of sine and cos and nothing else, like no number. You can divide through by cos. Works out nice and easy. However, if there is a number, not so simple. You have to change it into either just cos of addition angle formula or just sine of addition angle formula, and then you can solve it once it's in that form. You can go through the kind of simultaneous equations each time, or just Pythagoras of the coefficients and the arctan of the coefficients divided. And so what would you give yourself for that stuff? So we can do more exam questions with that next time, but I think you got it. Yeah, how was that for you, kiddo?
Good.
There's more trig. There's lots more trig. Do we do more trig next time or something else?
Maybe, but I'll let you know if we can do something else.
Okay. Any questions for me in general?
No.
Well done, Keelan. You did great. I look forward to talking again next week.
Yeah, you too. Are
you back in school next week?
Tomorrow.
Yay. All right.
No.
Yeah, finally. You kids.
No.
Aha. You sound like my daughter. All right. Well, have a good one. See you next week.
Thank you. Bye.